Okay, I have a couple more Hess's law of summation problems for you guys in this video, and then in the next video we'll do the other type of Hess's law. So let's do this one first. Okay, this is the same thing of the manipulation of the equations, okay, and then add them up and get this. So we have this right over here, this chemical reaction. We want to know the delta H for this equation. Now, we can add these two equations together somehow after we manipulate them to get this. And when we manipulate the delta H's, we will get this delta H over here. Okay, so we take a look at it. This is really not hard, guys. Just take a look at it and see what's similar and what's different. Okay, you notice that you've got 4 iron 2 oxides on the left here. Notice how you've got 2 iron 2 oxides on the right here? So what do you think you're going to have to do? You're going to have to multiply this whole equation by 2, so you get 4 iron 2 oxides, and flip it. If you do that, you're going to have this guy over in the right spot, okay? And do you notice that you have 2 iron 3 oxides on the right here and 2 iron 3 oxides on the right here? So honestly, you don't want to touch this second equation. This second equation looks like it's exactly where it needs to be. You don't need to multiply, divide, flip, do anything to it. So let's just leave this one alone. Let's just manipulate the top one. So what are we going to do? We're going to flip it and multiply by 2. So I'm going to go ahead and do that. Flip it. So this is what we're going to do. We're going to take this, flip it, and multiply by 2 all at the same time. So we're going to go 4 FeO solid will decompose to 4. Multiply by 2, multiply by 2. 4 iron solid plus 2 O2 gas. You see what we did? We took all these coefficients, the 2, the 1, and the 2, multiplied them by 2, and flipped. So what do we do to this negative 544? We multiply it by 2, so it's 1088, and change the sign since we flipped. So it's plus 1088. Okay? Good. Now let's take a look and see. Did we do enough? Well, see, you have 4 irons on the right. You have 4 irons on the left. You can cancel them out. Just get rid of them. Okay? You have 3 oxygens on the left and 2 oxygens on the right. So let's cancel out the 2 oxygens with 2 of these oxygens. So how many do you have left? You just end up having 1 oxygen left. Great. So if we add this to this, we'll have 4 iron 2 oxide plus 1 oxygen will give you 2 iron 3 oxides, which is exactly what we want over here. So now all we have to do is take the minus 648 and add it to the positive 1088. Add them together, and you end up with minus 560, if I'm not mistaken. Yep. So delta H is minus 560 kilojoules. Okay? That's how to do it. All right? So it's not hard. It's just that you have to look at each equation and see how it looks like the one you're going for. And then manipulate the equation, either flip it or multiply it by a number. But here's the thing a lot of students mess up on. They want to multiply one thing and then multiply the other thing in the reaction by something else. No. Whatever you do to one, you have to do to all of them. So choose the one that will make a difference. Okay? Good. So we're done with that. I have the second one already on the board. So I'm going to tilt the camera a little bit so you can see it. And then we'll go from there. Okay, so here we go. This is the one that I have. All right, so what we're going for is dinitrogen oxide plus nitrogen dioxide will give you 3 nitrogen monoxide. And you want the delta H for that, all right? And these are the three ones that you know. You know that 2N2 plus O2 will give you 2N2O. N2 plus O2 will give you 2NO. And N2 plus 2O2 will give you 2NO2. A little confusing because all the N's look alike and all the O's look alike, but they're different. How do I approach this? Well, I would just focus on these guys and see where they are over here and what coefficient is in front of them. Okay, so N2O, can you see that it's over on the left and you only have one of them? So what am I going to do to this first equation? I'm going to flip it and divide by 2. That's what I'm going to do. And if you flip this first one and divide by 2, you have to flip this and divide by 2 also. So first one becomes N2O. And why did I, by the way, why did I flip it? Because I see the N2O on the left here and it's on the right here. So I flipped it that way. And why did I divide by 2? Because here I have 1 and here I have 2. That's why I divided by 2. I'm going to divide everything by 2. So you're going to have N2O over on this side. Dinitrogen oxide will decompose to form nitrogen plus half. Remember how I told you guys in the first video that you are allowed to have fractions in a thermochemical equation, half a mole of O2 gas. Okay, so I divided everything in this equation by 2 and I flipped it. So I have to do the same thing to this plus 164.1. So plus 164.1 flipped is it becomes negative. Divided by 2, it's negative 82.05. So this is the delta H in kilojoules. Okay, that's the first one. Good, I'm done with this one. Now I take a look at the second one. The second one has NO on the right. Good, we want NO on the right, so we're not flipping the second one. But look, it's got a coefficient of 2, but we want a coefficient of 3. How do we turn the 2 into 3? What do? We multiply by 3 halves. So if I multiply this by 3 halves, then I get rid of the 2 and I have a 3. And I don't need to flip it because I already have it on the correct side. So it means that I need to multiply everything by 3 halves. This has to be 3 halves, this has to be 3 halves, and this 180.5 has to be multiplied by 3 halves. So I'm going to go ahead and do that. We're not flipping it, so we're going to say 3 halves N2 gas plus 3 halves O2 gas will give you 3 halves times 2 is 3, which is what we want, 3NO gas. Okay, now I have to do that 180.5, multiply it by 3 halves, and you get plus 270.75. So let's multiply by 3 divided by 2. Okay, good. All right, we're done with this one. Now we focus on this one. Notice we have an NO2 on the right. Do I want an NO2 on the right? Nope, I want an NO2 on the left. And I only want one of them. Can you see how this is just 1 and this is 2? So what do? I'm going to need to flip it and divide by 2. Flip it, divide by 2. All right, let's go ahead and do that. Flip, divide by 2. Everything has to be divided by 2. So I'm going to have an NO2 gas on the left, and it's going to decompose. I have to divide this by 2, so I'm going to have a half N2 gas. And divide the O2 by 2, that'll just be 1, plus O2 gas. This has to be flipped, so it becomes negative, and divide by 2, so I'll have a negative 33.2. Negative 33.2. Okay, I did everything I possibly can do now. Now I just need to see if I end up with this. Let's see what happens. Okay, I have an N2O on the left, which is what I want. I have an NO2 on the left, which is what I want. And I have a 3NO on the right, which is what I want. Let's see about all this clutter of N2 and O2. On the left, I've got 1.5 N2s. I have 1.5 nitrogens. On the right, I have 1.5 nitrogens. Yay, good. We can cancel out all the nitrogens. On the left, I have 1.5 oxygens. On the right, I have 1.5 oxygens. I can cancel out all the oxygens. Wonderful. So what am I left with? Exactly what I'm looking for. N2O gas. These things always work out beautifully, guys. If you target correctly, and honestly, it's really hard not to target correctly because all you have to do is just relate the ones that you're given to the ones that you want to end up with, and just focus on the things you should be manipulating, and then everything falls into place beautifully. And then this becomes 3NO. So we already know that these have been manipulated right. We already know that they have all the correct signs, and you add them up, minus 82.05 plus 270.75 minus 33.2, add them, and you end up with positive 155.5 kilojoules. So this is an endothermic reaction because we ended up with a positive value, and that is how to do this interpretation of Hess's law. In the next video, we're going to talk about a concept called delta H of formation, and that concept will help you understand the second interpretation of Hess's law, and I think that will help us wind up this chapter, or at least the key things I want you to know from this chapter. Okay? Good. Practice, okay?